In cylindrical coordinate system, any point is represented using three coordinates: rho, phi and z. Rho is the radial distance of the point from the z-axis. Phi is the angle made by the half plane containing the required point with positive x-axis. And z, it is exactly the same as we have seen in Cartesian, perpendicular distance from the xy plane. So in cylindrical coordinate system, we have three coordinates: rho, phi and z. So let us dive into details. So let us talk about rho first. As I just said, rho is the radial distance of the given point from the z-axis. For example, if point P is like this, then its radial distance is nothing but the perpendicular distance from the z-axis like this. So rho for this point can be shown like this. If point P is like this, then again rho can be shown like this. It is the perpendicular distance from the z-axis, or we can say a radial distance. Actually, you know, my dear, for getting the rho coordinate of the point, we assume that a hypothetical cylinder centered around the z-axis is passing through the required point, and rho coordinate of that point is nothing but the radius of this cylinder. For example, if point P, again consider point P is like this. So we assume a hypothetical cylinder centered around the z-axis like this, and rho is the radius of this cylinder. Rho coordinate of this point is the radius of this cylinder. If point is like this, again we will consider a hypothetical cylinder that is passing through the point. The cylinder must be centered around the z-axis as shown in the figure, and rho coordinate of this point will be the radius of this cylinder. The second coordinate is phi. It is the angle in the xy plane. It is the angle made by the vertical half plane containing the required point with positive x-axis. Let us understand it pictorially. Let us assume that point P in the space is present as like this. So the vertical half plane is nothing but the plane containing the required point and the z-axis, and this plane is assumed to be stuck at the z-axis as like this. So this is the vertical half plane containing the required point, and the angle made by this vertical half plane with this positive x-axis is called as the phi. So for this point, the phi is like this. If the point P is like this, then again the vertical plane will be like this, and according to the definition, phi will be this angle, as you can clearly see from the diagram. So remember very carefully, phi is the angle made by the vertical half plane containing the required point with positive x-axis. Now very important, this angle phi must be traced in the anticlockwise direction from the reference. That means for getting the phi, you should move from plus x plus y, then minus x minus y, then back to plus x. The normal positive direction for defining the phi is anticlockwise direction from the reference. For example, if point P is like this, then the vertical plane containing this required point is as shown in the figure. So my dear, phi can also be like this. Let us say it is a 60 degree, or phi can also be like this. Let us say it is a 300 degree. Because you know, what is phi? It is the angle between the vertical half plane containing the required point with the positive x-axis, and both the diagram showing the same. Both can be our phi. So my dear, which one will you take? Will you take 60 degree or will you take 300 degree? In such case, remember always, the normal positive direction for defining the phi, for tracing the phi, is in anti-clockwise direction. You should move from plus x, plus y, minus x, minus y, then back to plus x. You should move like this. So according to our definition, according to our normal definition of the phi, this will be our required phi, 300 degree. Because for getting this phi, you are moving in the anti-clockwise direction. Look carefully in the diagram. So in this case, our required phi is 300. This is not our required phi. Look carefully. For getting the 60 degree, you are moving from plus x minus y. You are moving in clockwise direction. So this is the normal positive direction for defining the phi. The normal positive direction for defining the phi is anti-clockwise from the reference. And the clockwise measurement should be considered as negative phi. So this same angle 300 degree, you can also write it as a 60 degree, but with negative sign. So the angle phi 300 degree is also equal to minus 60 degree. So my dear, remember like this. For defining the phi must be traced in anti-clockwise direction from the reference. The normal positive direction for the phi is in anti-clockwise direction. But if you trace it in the clockwise direction from the reference, then you should write that phi will be negative, as like this. 300 degree and minus 60 degree. They both are same. And last coordinate z, it is exactly the same as we have seen in the Cartesian coordinate system. It is one and the same. The perpendicular distance from the xy plane. If that distance is in upside, you should take positive z. If it is in downside of the xy plane, it should be negative z. So it is exactly the same as we have seen in the Cartesian coordinate system. So my dear, this is how any point in the space is located using cylindrical coordinate system. Each and every point can be represented with 3 coordinates, that are rho, phi and z. Rho is the lateral or radial distance of the point from the z-axis, or it is also the radius of the hypothetical cylinder that is assumed to be passing through the given point. Phi, it is the angle made by the half plane containing the required point with positive x-axis, and z, it is the perpendicular distance from the xy. Now let us see what are the maximum values these rho, phi and z can take. If I want to cover the complete space, what will be their ranges? So first of all, let us talk about the rho. My dear, recall the definition of the rho. What is rho? It is the radial distance of the given point, the minimum perpendicular distance of the given point from the z-axis. Am I right? So if point P is like this, let us say at a distance of 2 units from z-axis, then its rho will be 2. And if point P is like this, let us say at 4 units from the z-axis, then its rho will be 4. My dear, you can notice one thing over here, a very important thing. Rho can never be negative. It may be 0, but it cannot be negative. Whatever be the position of point, in the space, rho is the minimum perpendicular distance, radial distance from the z-axis. So it cannot be negative. Either it point is in front, side, back side, whatever. It is the distance from the z-axis. So rho can never be negative. Rho may be 0. If point is perfectly on the z-axis, then its distance from the z-axis will be 0. So rho will be 0. Rho can be 0, but it cannot be negative. Actually, as I have explained before, for getting the rho coordinate of the given point, we assume that a hypothetical cylinder around the z-axis is passing through the given point. Am I right? And rho coordinate is nothing but the radius of that hypothetical cylinder. If point P is like this, then we assume that a hypothetical cylinder like this around the z-axis and rho coordinate of this point is nothing but the radius of this cylinder. And if point P is like this, then we will assume the hypothetical cylinder like this. And rho of this point will be the radius of this cylinder. And my dear, radius of any cylinder can be 0, but it cannot be negative. Am I right? So what I am trying to convince you, the value of the rho coordinate can never be negative. Its minimum value, its starting value is 0, and maximum value can be up to infinity. The point can be anywhere in the space. It can be at a distance of 2, 400, 200, 400, whatever. Point can be present at any distance up to infinity. So its maximum value can be up to infinity. So the range for the rho coordinate will be from 0 to infinity. Now let us talk about the range for the phi. What are the maximum values that phi can take? My dear, remember about phi. Phi is the angle. It is the angle made by the vertical half plane containing the required point with reference positive x-axis. We have also seen that we look the phi in anticlockwise direction. Am I right? So if point P is like this, then phi can be shown like this. Whatever be the position of the point in the space, first of all, for getting the phi, we consider a vertical half plane containing the required point and the z-axis like this. And then we look at the angle between the reference positive x-axis and that vertical half plane. Whatever be the position of the point, we look the angle between plus x-axis and that plane, vertical half plane. So if point P is like this, then phi will be like this. If point P is like this, then phi will be like this. So point P can be anywhere in the space. So you can easily see from the diagram, to cover the complete points from the space, this vertical half plane can take any position from here to here. Am I right? So this vertical half plane can make one complete rotation to cover the complete space. In other words, phi can take any value between 0 to 360 degree or 0 to 2 pi. So the range for phi will be from 0 to 2 pi. And already you know the range for z, it is exactly the same as we have seen in the Cartesian coordinate system. Z is the perpendicular distance from the xy plane, and it can be anywhere in between minus infinity to plus infinity. So it is exactly the same as we have seen in the Cartesian. So overall, in our cylindrical coordinate system, we have three coordinates: rho, phi and z. Rho, the range for the rho is from 0 to infinity. Range for the phi is from 0 to 2 pi. It is the angle. And range for z, it is from minus infinity to plus infinity.